Today we will do some questions on electromagnetic waves. This is your question number 1. A plain electromagnetic wave of frequency given 25 MHz travels in free space along the x direction. The wave is traveling along positive x-axis. So the velocity of wave is along positive x-axis. At a particular point in the space and time, E is equal to 6.3 j cap. Unit vector given is j cap. So the electric field will be along y-axis only. Now what is the magnetic field vector B vector at this point? So now we know that the velocity of light is given as the ratio of magnitude of electric field to magnitude of magnetic field. From here we can find magnitude of magnetic field. E is given 6.3 volt per meter and C is your 3 into 10 to the power 8 meter per second. I have calculated this value from before. It is equal to 2.18 into 10 to the power minus 8. And the SI unit of magnetic field B is Tesla. So this is the magnitude of magnetic field. Now for direction. The velocity vector is equal to cross product of electric field and magnetic field. And it is along I cap direction. Electric field is along j cap direction. And this is the direction of magnetic field that we need to write. Now we know that I is equal to j cross k. So therefore B will be along k cap. Along positive z axis. So answer, this is question number 1. Now question number 2. The magnetic field in a plane electromagnetic wave is given by this equation. What is the wavelength and frequency of the wave? Question number B is, write the expression for the electric field. So I'll be writing first of all the standard equation of an EM wave in terms of magnetic field. So this is equal to magnetic field amplitude sine, and here you can see it is written in terms of something number into x plus then some number into x. So in place of that you can write kx plus omega t. And now you will compare the two equations and you will find that the right hand side is equal. The left hand side should also, each terms of the left hand side should also be equal. So on comparing these two equations 1 and 2, you will find that kx is equal to 0.5 into 10 to the power 3x. From here, now x is cancelled from both the sides and k, which is equal to wave number, and this is your 2 pi upon lambda, is equal to 0.5 into 10 to the power 3. Therefore, you have to find wavelength. So wavelength lambda is equal to 2 into 3.14 divided by 0.5 into 10 to the power 3. So this is the value of lambda, and I have already obtained its value 1.26 into 10 to the power minus 2. And wavelength is measured in meter, in the unit meter. This is your first answer of question number A of 2. Now second question, what is the frequency? Now this time you will be comparing angular velocity with that of this term. Now since on comparing 1 and 2, angular velocity omega is equal to, just prefix of t, it is written 1.5 into 10 to the power 11. And we know that angular frequency is 2 pi n is equal to 1.5 into 10 to the power 11. So it implies that frequency n is equal to 1.5 into 10 to the power 11 divided by 2 into 3.14 Hertz. So I have already obtained its simplified value, and this is your 23.9 Hertz. Now question number B. Write the expression for the electric field. So for writing expression for electric field, you know that in an EM radiation, the phase is same. The same value you will be writing in the expression of electric field also, in place of phase. So you have to obtain only this electric field amplitude. E is equal to E amplitude sine kx plus omega t. So all these things are given. You have to write equation of electric field. So you will find only electric field amplitude by the equation C is equal to Em upon Bm. Therefore, Em is equal to, Bm given is 2 into 10 to the power minus 7. And C is your 3 into 10 to the power 8. And electric field is measured in unit of Newton per Coulomb. So this is equal to 60 Newton per Coulomb. Now we can write equation for electric field. E will become equal to, here you have from this equation number, I should write A. From A, E is equal to 60 sine, and from this equation, because the phase angle of magnetic field and phase angle of electric field will be same. So it is your 0.5 into 10 to the power 3x plus omega, and omega is your 1.5 into 10 to the power 11 t. So this is your electric field of electromagnetic radiation. This is your answer of question number B. Now next question. Question 3. Electromagnetic waves travel in a medium at a speed given. Speed is given. The relative permeability of the medium is 2. Find the relative permittivity of the medium. So we know that velocity of light in any medium is equal to under root 1 upon epsilon into mu. But epsilon or mu is not given. It is given relative permeability. So we will convert mu into mu r mu naught. Mu is equal to mu r into mu naught and E is equal to ER into E naught, where mu naught is absolute permeability, E naught is equal to absolute permittivity, and mu r is your relative permeability. Now we will be writing all the values. Speed is given 1 into 10 to the power 8 is equal to, and you know that this term, this very term, root under 1 upon mu naught epsilon naught. This term is called velocity of light divided by root under, and mu r given is 2, and you have to find value of epsilon r. Now therefore root under 2 into epsilon r is equal to 3 into 10 to the power 8 upon 1 into 10 to the power 8. Now squaring the both sides of the equation, you will find that 2 into epsilon r is equal to 9, and therefore epsilon r is equal to 9 upon 2. That is your 4.5. So this is the value of epsilon r. Now next question. Question number 4. A plane electromagnetic wave propagating in x direction has a wavelength of 5 mm. Wavelength lambda is given 5 into 10 to power minus 3 meter. The electric field is in y direction and its maximum magnitude is 30 volt per meter. Write suitable equations for electric field and magnetic field as a function of x and t. So we know that a traveling wave and EM wave in terms of electric field is equal to E amplitude into sine, and we have to write in terms of x and t. So we will contain x and t. Sine omega t minus x by velocity of light c. So these things we have not changed. We have to put value of omega and your electric field amplitude. And it is given, electric field amplitude is given 30 volt per meter. So equation of electric field is equal to 30 sine, and in place of omega we will be writing 2 pi n, and in place of n you will be writing c upon lambda, because c is equal to n lambda, and here you have t minus x by c. So let us simplify it. E is equal to 30 sine, and your wavelength is given 5 into 10 to power minus 3 and t minus x upon c. So here is an electric field, EM electric field, sinusoidal varying electric field, which is written in terms of time and x. Now we have to write magnetic field. So for writing magnetic field in an EM radiation, it is for sure that the phase of electric field and phase of magnetic field will be the same. So only thing which is varying is this E amplitude, and this B amplitude we need to find first of all using this equation of your velocity of light. C is equal to EM by BM, magnetic field amplitude, Therefore, Bm is equal to 30 upon 3 into 10 to power 8 Tesla. Magnetic field is written in terms of Tesla. And this comes equal to 10 to the power minus 7 Tesla. Now you can write equation for magnetic field. Magnetic field is equal to Bm sine omega t minus x by c. So now let us put the values of all these. Magnetic field amplitude from here, it is your 10 to the power minus 7, and sine everything I will be repeating from the wave of electric field. This is your 2 into 10 to the power 2 into 3.14. Okay, 2 into 3.14 divided by 5 into 10 to the power minus 3 t minus x by c. So this is the wave equation of time varying magnetic field, and this is your wave equation for time varying electric field. So now next question. Question number 5. A light beam traveling along the x direction is described by the electric field given here. An electron is constrained to move along the y direction. Okay, your electric field is along y direction. Here you have electric field, and the velocity of wave can be obtained from here. Velocity is along x direction. And this velocity given is 2 into 10 to power 7 meter per second here. Find the maximum electric force and maximum magnetic force. You have two questions. Number 1, maximum electric force. Electron is forced to move along y-axis. Here you have electron. Now you know that force electric is equal to Q into E. So this force will be in upward direction only, and charge on electron is 1.6 into 10 to the power minus 19, and electric field given, and this force amplitude, we need to find force amplitude, maximum force, so we need to take maximum electric field. And here this value is given is 300 volt per meter. So this comes equal to 4.8 into 10 to the power minus 17, and force has unit Newton. So this is the maximum electric force. Now we have to find maximum magnetic force also. So firstly we will find highest magnetic field using this equation, and we know that the speed of light is given by E amplitude upon B amplitude, and from this equation we can find magnetic field amplitude. E amplitude here is 300 upon velocity of light is given by 3 into 10 to power 8, and magnetic field has unit Tesla. So this comes equal to 10 to the power minus 6 Tesla. Now we obtain magnetic field, and we are to find maximum magnetic force. So this is your magnetic field amplitude. Now we will be applying Lorentz force F maximum will be equal to QV cross B maximum, and this is equal to for Q we will be writing value of electrons charge 1.6 into 10 to power minus 19, and velocity of this wave is 2 into 10 to power 7. And magnetic field amplitude is 10 to power minus 6, and these are along perpendicular direction. So sine 90 degree becomes 1. This is the magnitude of magnetic field, and this comes equal to 3.2 into 10 to the power minus 18 Newton. Now the direction of force. You have magnetic field along this direction, and direction of the force can be obtained by cross product of V and B. So this is your I cross K. This is your I cap cross K cap. And this is your minus of J cap. Minus 3.2 into 10 to the power minus 18. So this is your magnetic field force acting due to magnetic field in magnitude and direction.